All right, ladies and gentlemen, let's come back to this question here. So solve this inequality. 2 over absolute value of x plus 1 minus 2 is less than or equal to 3 over absolute value of x, where x cannot equal to 1, negative 3, or 0. So these are the what? These are the negative 1 and negative 3 are the vertical asymptotes of this, right? And 0 is the vertical asymptote of that. Okay, first step in solving absolute value inequality equation or drawing an absolute value graph. What is that? What is the first step? You find the 0, right? The 0 for each one of the absolute value expression. The first one is absolute over x plus 1 is set x plus 1 to 0. Solving for x gives us x equals negative 1. And there's another absolute value expression. And the 0 for it is x equals 0. Okay, so now we can draw a little number line as a visual aid to help us identify the regions. So we have negative 1 and 0 are the 2 0, right? But this is a rational, these are rational functions. Rational functions have potentially what? Vertical asymptotes. 0, which is a 0 for the absolute value expression. Is this a solid point or is this a vertical asymptote? This is a vertical asymptote, right? So I am going to draw a dashed line to give me a little reminder, to serve as the little reminder, the vertical asymptote. What about x equals negative 1? Is this a solid point or is this an asymptote, a vertical asymptote? It's not part of the restriction, right? So this is a solid line. This is a solid line. We have that. Okay. So, well, we also have these, right? We also have 1 and negative 3 that are also vertical asymptotes. So these are VAs, right? We already have 0 as one of the 0 for the absolute value expression. It's probably prudent to put down these two values in the overall number line just to be reminders. So these are also VAs. That's a VA, that is a VA. Okay. Now,
would the line be in front of 0 or?
Oh, sorry, 1 will be in front of 0. My bad. Can I borrow an eraser? Yeah. 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 1 will be right here. That's also a VA, right? Okay, so now let's explore the solution in each of these individual regions. For this region, for x less than negative 1. Okay, so x equals negative 1 is one of the zeros, one of the boundaries, right? Why did I not include negative 1 in it when I set this inequality? Okay, you group the equal, right, with the x values that would make the entity inside the absolute value positive or 0. Okay, so if you look at this, right, negative 1 is negative 1 is a boundary by virtue of x plus 1, right? So when x is less than negative 1, this is negative, right? So for x values that make the absolute value entity negative, we don't include it. Only when it's 0 or greater than 0, right? When x is -1, this is 0. When x is greater than -1, this is positive. So we group them together. Now, so for x less than -1, x plus 1 is negative. So absolute value of x plus 1 without the absolute value sign is x plus 1 multiplied by -1. Okay. And x is less than 0, right? X will be less than 0 and x is less than -1. So absolute value of x without the absolute value sign is -x. And I'm going to call this or label this equation 2. Okay, so that I can for documentation. So equation 2 without the absolute value sign is so 2 over -x plus 1 close bracket minus 2 less than or equal to 3 over -x. Simplifying this gives me 2 over -x minus 3 less than or equal to -3 over x, right? 3 over -x is the same as -3 over x. So now, remember when you solve a rational inequality, can you cross multiply? Generally not, right? Unless you know for sure that whatever expression that involves the independent variable is either positive or negative, not both, right? So, but you still have to make one side of the inequality 0. How do you do that? You can only add or subtract. So I'm going to add. Oh, I'm going to add. I'm going to add 3 over x to both sides. So this gives me 2 over, I'm just going to common factor out negative from -x minus 3 to give me 2 over x -x plus 3 in bracket plus 3 over x is less than or equal to 0. Now, I need to make this one single term, right? So to do that, I can multiply and divide the numerator and the denominator 2 over -x plus 3 by x, and multiply and divide 3 over x by x plus 3. So I have -2x plus 3 over x plus 3 divided by x plus 3 over x is less than or equal to 0. Expanding and simplifying gives me x plus 9 over x plus 3. X is less than 0. Okay. So now, all you need is to use the number line or the chart method, right? I have a list all the factors here. It's x plus 9, x plus 3, and x. Okay. So bear in mind that we are exploring or investigating the solution when x is less than -1. So -1. And that is, that is not inclusive of -1, right? So I'm going to put a dashed line, right? x is less than -1. So I can ignore all of this region. Now I'm going to put down the zeros for each of these factors. X equals 0, it's on this side, so we don't need to worry about that. So the 0 for x plus 3 is -3. And the 0 for x plus 9 is -9. Okay? When x equals -3, we have a vertical asymptote here. So that is also a dash line, because this is a vertical asymptote. What about x equals -9? Is it a solid line or is it a dash line? Is it an asymptote? It's not an asymptote, right? So it's a solid line. Okay. Now we can populate the chart with positive and negative signs, pluses or minuses, right? For each of these factors. So when x is less than -9, x plus 9 is negative. X plus 3 is negative, x is negative. When x is between -9 and -3, x plus 9 is positive, x plus 3 is negative, x is negative. Okay. When x is between -3 and -1, x plus 9 is positive, x plus 3 is positive, x is still negative. So the overall results are negative in this region, positive, and negative. And we are solving for x equals 0 or less than 0. So it's this and this. Yep.
So where does -1 come from?
-1 from here.
Oh, so
Right? So that is the region we are investigating, right? Because 0 is here. 0, we're not interested in 0 in this region, right? 0 is here, right? 0 is here. Okay? Yeah. So, yeah. Now, so we have our solution in this region. So based on the chart, the solution is x is less than, do we include -9? We do, right? Hey, we do. Because there's a less than or equal to -9. Okay. Or do we include -3? No, -3, it's a VA, right? -3 less than x. Do we include -1? No, because hey, -1 is not part of the region that we are interested in. We are exploring -1. So the solution in this region is these two, this region. Now we can move on to the second region. The second region is here. Hmm? You can, yeah. You can use set notation or interval notation. So this, do we include -1 in this? We do, right? Because we haven't included it. So -1 less than or equal to x, right? We include it if the value itself makes the entity of the absolute value 0, right? We include it. But do we include the 0? Do we include the 0? We don't include the 0. Do we include the 0 or not? We don't include the 0. Why don't we include the 0? It is a restriction, right? It is a vertical asymptote. This is a VA. Right? So we don't include it. So for x less than for -1 less than or equal to x less than 0, x plus 1, right? X plus 1 is what? is greater than or equal to 0. So absolute value of x plus 1 equals just x plus 1 without the absolute value sign. Okay. And well, if x is in this region, x will be negative. So absolute value of x will be, without the absolute value sign, is negative x. So equation 2, without the absolute value sign, I'm just going to use dot, 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 is 2 over x plus 1 minus 2 less than or equal to 3 over negative x. So simplifying gives me 2 over x minus 1 less than or equal to negative 3 over x. Now to make the right side 0, all I need is to add 3 over x to both sides. So I have 2 over x minus 1 plus 3 over x is less than or equal to 0. Consolidating these two fractions gives me 2x plus 3x minus 3 over x minus 1 times x is less than or equal to 0. Simplifying gives me 5x minus 3 over x minus 1 times x is less than or equal to 0. Now I can do the same thing by to solve this inequality. I can use the chart method, right? Or the number line method. Okay, and of course, now this is the region we are investigating, right? Between -1 and 0. 0. We include -1. So I'm going to use solid line. We don't include 0 because 0 is a VA. This is a VA, a vertical asymptote. Okay, so we don't care about these regions. Now list all the factors in the rational expression. I have 5x minus 3. I have x minus 1, and I have x. Okay, so now let's put all the zeros for each of these factors. 0 is there. -1 is there. What about this? What is a 0 for 5x minus 3? 3 over 5. 3 over 5, is it in this region? No, 3 over 5 is here, right? So that's 3 over 5. So yeah, so we don't need to worry about the 0 for that. Now just populate the chart with pluses or minuses. So when for 5x minus 3, in this region, it is negative. In this region, x minus 1 is also negative. In this region, x is also negative. So we really only have one region, and the net result, the net sign for this region is negative, right? So negative, what is the solution? Right there, right? So this entire region, it's the solution. So based on the chart, the solution is -1. Do we include -1? We include it. And 0. That is the solution for this region. All of it. Right. Part 3, well, the third region. Here. For x, do we include the 0? We haven't included it, but we're not going to because this is a VA, right? For x greater than 0. So x plus 1 is positive. So absolute value of x plus 1 is, without the absolute value sign, is x plus 1. And well, since x is greater than 0, so absolute value of x without the absolute value sign is just x. Thus, equation 2, without the absolute value sign, is 2 over x plus 1 minus 2 less than or equal to 3 over x. So 2 over x minus 1 less than or equal to 3 over x. To make one side 0, I can subtract 3 over x from both sides of the inequality to give me 2 over x minus 1, take away 3 over x is less than or equal to 0. And of course, I can consolidate these two fractions to give me 2x minus 3 times x minus 1 over x minus 1 times x is less than or equal to 0. Simplifying gives me negative x plus 3 is less over x minus 1 times x is less than or equal to 0. Okay, so using the number line method, okay, I'm solving for, in this region, x greater than 0. So 0. I'm not including 0 because x equals 0 is a VA. This is a VA, right? Vertical asymptote. So, and I'm only interested in x that's greater than 0 for this region. Now list all the factors in the inequality. So we also, don't forget, we also have 1 there. 1 is a VA, right? So I'm going to put in the 1, which is a VA from the original inequality. This is a VA. Right? Now, let's put down all the zeros for this. So we already have the 0 for x. It's covered with a 0 for x minus 1. What about a 0 for negative x plus 3? It's 3, right? It's 3. Is 3 a VA, vertical asymptote, or is 3 a solid point? Solid point, right? Hey, negative 3 is a VA, not 3. Okay, so this is a solid point. Or we use solid line to represent it. So there are 3 distinct regions that we have to investigate. Okay, so now we populate the chart with pluses or minuses. Between 0 and 1, negative x plus 3 is positive. This is negative. This is positive. Between 1 and 3, this is positive. This is positive. And this is positive. Greater than 3, this is now negative, right? Because it's negative x plus 3. And this is positive, and this is positive. So the net results are negative in this region, positive in this region, and negative in this region. And since we are solving for less than or equal to 0, we have 2 regions that would satisfy this inequality. So based on the chart, the solution is, so 0 less than x less than 1, or x is greater than or equal to 3. So the thing that you have to keep in mind is when you're solving inequality of absolute value involving rational function, you have to be mindful of the vertical asymptotes. Okay. Now I'm just going to list the overall solution. Hence, the solution for inequality number 2 is, so the first one is x is less than or equal to -9, or -3 less than x less than -1, or -1 less than or equal to x less than 0, or 0 less than x less than 1, or x is greater than or equal to 3 as required. Okay. Any questions? Absolute value is fun. Absolute value is like chili pepper, like in cooking. You add a little bit of chili pepper, all of a sudden everything is spicy. Like your trigonometry dish, your logarithmic dish, your exponential dish, your rational function dish, right? So it's chili pepper. It was like sriracha, like sriracha sauce, right? Okay.